Okay, hello, welcome back. Today we are going to be, or in this video, we are going to be looking at ionic bonding. It's a very common question that comes up in AQA Chemistry Paper 1, and it's one of those ones where you can often get a 4, 5 or 6 mark question on it that you should be really confident in answering, so hopefully this video will be able to get you there. So first things first, let's have a look at what are prerequisite or required knowledge that we need for this topic. So the main thing that you're going to need to know about is electronic structure. Handily, I have just released a video before this one on electronic structure, so I'm not going to go through that here, but if you're not sure about electronic structure, then go through, watch that video, have a go at those exam questions, and then come back and jump into our ionic bonding. The other thing you need to be aware of before we go into here is how atoms become ions. So if we look at this here, so this is going into our electronic structure, if we take lithium, which as we said has 3 electrons that are arranged like this. Now, it has 1 electron in its outer shell. The way that atoms become ions is that they become charged. So they go from neutral atoms, no charge, to ions, which are charged, which can be a plus or a minus. So in a minus. In lithium's case, what it does is it loses this outer shell electron here. Okay, so now it only has 2 electrons. If I could spell. So 2 electrons, but atomic number of 3, it's still got 3 protons. This has now become positive to a charge of +1. So electrons are negative, protons are positive. There's 3 pluses, 2 minuses, that balances out to +1. If we have a look at another example, for example, we'll take one that we did last time. So if we take magnesium, 24, 12, it has 12. Oh, I've given myself a big job here. Now really those should be much more equally spaced as we go around, but it has 2 outer shell electrons. So what it does is it loses those 2 outer shell electrons. So it becomes, and now it becomes a charge of 2 plus. So all of our metals pretty much form positive ions. Now, if we take a look at a non-metal, so we're going to use oxygen as an example. It has 8 electrons and 8 protons to start with. So 1, 2, 3, 4, 5, 6, 7, 8. So it wants to have a full shell. What it does is it borrows 2 electrons from somewhere else. I'll show those in a different color. And it now has a full outer shell and has become, because it's got 2 extra minus charges, an ion with 2 minus. Now, if you're still not sure about that, that's fine. Go away, revise it, and then come back, because we do need to understand this really well for us to be able to apply it to ionic bonding, and it's not the focus of this video. So let's take an example. Salt, or table salts, because salts have a scientific purpose as well, which is NaCl. So first things first, we're going to look at our atoms. Okay, as you can see, sodium has an atomic number of 11, so it has 11 electrons. I'll fill that in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and chlorine has 17. So I'll fill those in as well. I'm going to use a different color to make it nice and easy for us to tell. So we've got 10 on so far, so we need 7 more. One more, there we go. So we've got, these are our atoms. So these are our neutral atoms. And in the process of ionic bonding, we know that sodium needs to lose an electron to become positive and form an ion, and chlorine needs to gain an electron to become negative and form an ion. So what happens is this electron here comes all the way over here and plonks into the chlorine, which produces the ions that I will show you below. So as you can see, both of these now have a charge. So what happens is there is a strong electrostatic attraction between them, which causes them to form strong bonds. So that's the process for ionic bonding. The only difference is sometimes it could be different atoms which have different numbers of electrons in their outer shell, but just the thing to remember is they always want to have a full outer shell. So in both these cases down here, we have a full outer shell in this one and in this one. That's what we're going for. They always want to have a full outer shell during ionic bonding. That's the important thing to remember. So if you've got 6 in your outer shell, to get to 8, it's easiest to add 2. If you've got 3, you're going to lose 3. So let's have a look at how we would write that out for an exam question. So here's a very classic exam question. You could have it at 4, 5 or 6 marks. I personally would recommend using bullet points to organise your thoughts here, because it makes it really easy to see if you skipped something, and also really easy for an examiner to identify where you have hit the mark scheme. So, D, describe what happens when a sodium atom reacts with a fluorine atom to form an ionic compound. And handily, they've actually provided us with a diagram. So we can see here in this diagram, we've actually got most of the information already. Sometimes they're not as kind as this, but always use your diagrams as well as you can. So we can see that our sodium atom has started with an electron in its outer shell and now has no electrons in its outer shell, or it has a full outer shell in the shell below. Fluorine has started with 7 and now has 8. We can see that this dot here, this electron, has jumped over to our fluorine atom. So we can make this very simple. Now, ionic bonding is something where you can get marking points for several points within a sentence. So when I break this answer down, remember, sometimes we're going to be doing bullet points that aren't a full sentence because it's a marking point, but sometimes these marking points aren't requiring lots and lots of writing. So first things first, we'll say sodium loses 1 electron. Sodium becomes positive. So there we go, that's actually 2 marks, saying sodium loses an electron and becomes positive. Now, the next part we need to talk about is what happens with that electron. So the electron transfers, and transfer is quite a key word here. I would always use electron transfer when we are talking about ionic compounds, just because it makes it very, very clear what you are trying to say. So the electron transfers to the fluorine. Okay, so that's another mark. And then what happens to the fluorine if it's gaining an electron? What's happened to it here? It becomes negative. So the fluorine becomes negative. So now you might say to me, well, we fully described this, what's going on? But we can still eke out another couple of marks when we talk about our keyword that begins with E. So can anyone remember what it is? It's a strong electrostatic attraction. And this is another point that we bring in from elsewhere, because opposites attract. So there would be 6 out of 6, so 6 marking points for what could be 2 or 3 sentences only. So don't be afraid when you see one of these questions and you've got a whole page of writing. If you fully described it scientifically using our keywords like electrostatic and transfer, you can get your 6 marks. As always, I hope this has helped you really solidify your understanding of ionic bonding. If there are any other topics you'd like me to cover, please let me know.